Hello and welcome to Today I Learned Climate. I'm your host, Laur Fisher from the MIT Environmental Solutions Initiative. In our last episode, we talked about using technology to suck extra carbon dioxide from the atmosphere. But you might also be thinking, don't trees do that? Yeah, they do. In fact, some people have proposed that by planting enough trees, we could make a big dent on climate change. And there are companies and online calculators that say that you can cancel out your own carbon emissions by planting trees. So today we've brought on a guest to help us answer the question, could we just plant a whole lot of trees to solve our climate problem?
My name is Charles Harvey, and I'm a professor of environmental engineering at MIT.
So before we started recording, we heard your dog barking. What kind of dog is it? What's their name?
So that's, right there, Goya, our Bernese mountain dog, who just got back from skiing, and I locked her in the bedroom so that you wouldn't hear her barking.
So now it's all blatantly obvious that we're creating these podcasts from home during COVID. You will hear Goya throughout this interview. Okay, so we all probably learned in school about how trees and plants suck up CO2 and produce oxygen through photosynthesis. But if you're feeling a little rusty on how all this works, you're not alone.
A couple years ago, someone did a poll of graduates at Harvard graduation to determine what basic science knowledge they had. And one question they asked was, where do trees come from? Where does the material in a tree come from? Does it come up the roots from extracted material from underground? Or does it come out of the atmosphere? And most of the graduates thought it came out of the ground. The truth is that most of the tree, the solid material in the tree, is carbon that is pulled out of the air. So gaseous carbon dioxide in the air is turned into wood and roots and leaves by the tree through the process of photosynthesis. And as the plants die, the roots are left behind, leaving carbon in the soil. So there's a whole ecosystem of things made out of carbon and of organic carbon from long dead things existing down in the soil.
So picture yourself on a hill above a forest, looking out on miles and miles of tree trunks and leaves. All that is made out of carbon pulled, out of thin air. And the roots and soil under the forest, too, are chock full of carbon that was once floating up in the atmosphere. But there's a cycle that's happening here. Carbon both enters and leaves the forest.
As the plants die, they degrade. Insects, microbes eat them and release carbon dioxide back to the atmosphere. That's the way the biology on Earth works.
It's like a forest breathes carbon in, stores it in its trunks and branches and acorns and leaves and roots, and then breathes it back out again as all that stuff decomposes.
One way to think about the terrestrial carbon cycle is that you've got this uptake and this release. And the system likes to find a state where the two are equal to each other. And a lot of mature forests are like that. Even though the trees are pulling carbon dioxide out of the atmosphere, that same amount of carbon is being released as carbon dioxide back into the atmosphere.
So you could say that when a new forest begins to grow, it's like a huge vacuum cleaner for CO2, rapidly pulling carbon out of the atmosphere. But eventually, it becomes a mature forest, which is actually breathing out as much carbon as it's breathing in. At that point, it's more like a big vault, like a bank vault, for CO2. Trees make a little CO2 deposits and withdrawals as they breathe in and out, but overall, the amount of CO2 in the vault stays the same, locked up and out of the atmosphere. So if we planted a whole new forest, that would take a lot of CO2 out of the atmosphere, right?
Oh, yeah, it's true. I mean, if you go to a field and grow a forest on it, you now have all these trees that are composed of what was carbon dioxide. Trees are tremendously efficient and plants in other ways, like they grow themselves, they reproduce, they cover land. You don't have to build machinery that covers everything. So I think in the long term, nature-based solutions are actually more efficient than some sort of mechanical direct air capture.
This is great! A natural way to capture and store carbon. Plus, everybody loves trees. So, how much carbon can we expect to vacuum up when we plant our beautiful new forest? Well, here's where the trouble starts. Scientists can't actually agree on an answer.
This is the area of the carbon cycle that we know the least about because it's really hard to measure. We don't really understand all of the uptakes and releases from a forest. We don't really understand how much is taken up into the soils and underground over time. It's relatively new to try to measure these things accurately enough over large areas over a longer period of time. And the approach that's usually taken is with something called an eddy flux system, where we build something that looks like a cell phone tower over a forest and measure the flux of carbon dioxide in or out of the forest.
How does it work?
The way it works is that you measure carbon dioxide concentration and you also measure the vertical velocity of the air in the atmosphere. And then, roughly speaking, you can get the flux over fractions of a second, little bits up and down, and integrate that over years.
That is so cool.
Yeah, it's a real pain in the ass, I'll tell you. But the difficulty is that they're two big fluxes, and we're looking for the small difference between the two.
So there's uncertainty about how much carbon a forest can actually hold. And that's a big deal if you're trying to plant trees as the solution to climate change. And actually, we should probably stop saying planting trees and start saying planting forests. Because we're talking about billions of acres of trees here. For some perspective, the landmass of the US is about 2 billion acres. Which brings us to another issue. Where do you plant these forests? Because most land that doesn't have forests on it already is being used for growing crops and livestock.
Before there was agriculture, other things grew on these soils. The Midwest large parts of it were forested, so the soil was much thicker. And modern farming practices lead to a soil that's sort of thinner and has less organic carbon in it.
So a lot of our agricultural land could probably store more carbon if we turned it back into a forest, but we'd have to find some other way to feed ourselves. And other types of land, like deserts, just aren't suitable for growing trees. And get this, areas like wild grasslands and marshes are already doing a good job of storing carbon. So trying to turn those into forests might be counterproductive. You can see how tricky it starts to get when you think about planting forests on a really large scale.
Another thing that makes it very difficult is what happens to the tree? Is the tree cut down and made into toilet paper that then goes back into the air? Or is the forest, which you've planted, allowed to continue to mature and last for a long time?
Right. If the trees decompose or are burned, then all of that carbon we've stored there goes back into the atmosphere, including the carbon in all of those forests that burn in wildfires in the western US. In our world today, we have a lot of challenges with keeping forests intact. This is key because everywhere forests are being cut down, we're actually making climate change worse.
Cutting down a forest releases carbon dioxide into the atmosphere in two main ways. The first is kind of obvious. All of those trees and plants are carbon, and once they're cut down, they degrade. The second area is that when you cut down the large trees, the deep roots die. And the roots are an enormous store of organic carbon in the soil, which is turned into carbon dioxide.
30% of the Earth's land is already covered in trees, including vast forests like the Amazon, the Congo, and in Canada and northern Eurasia. These are massive vaults of carbon, and today, humans are breaking into them. Maybe the best example of this is the ecosystem where Professor Harvey does his research in Indonesia and other parts of Southeast Asia.
I work in the tropics in what are called tropical peat swamp forests. And these look like rainforest, enormous tropical rainforest trees. But the soil is very wet, sort of puddles everywhere. And if you dig down into it, it's all basically vegetative matter. So peatlands are unique ecosystems in that for thousands of years, peatlands do not reach equilibrium. In a peatland, the uptake of carbon dioxide for photosynthesis is larger than the degradation, and that results in buildup of a soil that is pure organic carbon. That's what peat is. And when they're damaged or degraded, they release enormous amounts of carbon to the atmosphere because the soil is entirely carbon. Just in the last 10 years, almost all of these forests have been cut down and replaced with agriculture, mainly palm oil. So once the peat is dry, it just becomes flammable everywhere and burns in these enormous fires that emit these huge plumes of toxic haze that cause a lot of sickness, death, and close down economic activity across the region.
This, as you can imagine, is terrible for the people living near these forests. It's also terrible for all of us. Those plumes of haze are, in large part, CO2. And once it's in the air, it will be warming our planet for centuries to come. So yeah, plant forests. But if we're looking to harness the power of trees to help us with climate change, the math shows us that first, we should be protecting forests.
We know that deforestation releases CO2, so we adjust our practices to not deforest or to extract lumber in a more sustainable way. And then in the long term, turn that around and start to pull carbon dioxide out of the atmosphere. I think it has a lot more potential in the long term after we've eliminated fossil fuel emissions to actually lower atmospheric concentrations.
If you're itching to dive deeper into what we talked about today, we've provided resources in our show notes at tilclimate.mit.edu. Just go to the episode page. And educators, we've developed a flexible set of activities to connect this episode with your classroom curriculum. Check out climate.mit.edu/educators. You can also learn about the work that we're doing at the MIT Environmental Solutions Initiative to help communities in the Amazon integrate technology and new business models to protect the rainforest. That's our Natural Climate Solutions program, which you can find at esi.mit.edu. Thanks to Professor Charles Harvey for joining us on this episode, as well as Professor César Terrer for his insights as well. And thank you for listening.